Bismillahirrahmanirrahim. Welcome to Easy Learn, and we are going to start another new topic that is relevant to the previous topics, of course. Today's topic is we are going to simplify a network. That is the main goal of discussion, all previous discussions, because we see that, for example, we have a PCB here and we are designing. Let's suppose in 1980s this PCB has 4 resistance, let's suppose 4 components, and after 2 years, 4 years, this we had company added some new features in this PCB, and for adding new functions, another important step is to maintain the cost so that it's not going out of budget, and secondly maintain the size of this machine. For example, let's suppose this is a smartphone, and if we are going to change it into another, next project should be number one task is to reduce the size of this PCB, and the second task is to reduce the cost as well as improve the performance. We added a new function. For example, we need to add resistance here, but we have to remain in the mind that these resistors are not with 3, but we can reduce its size in such a way that by applying all of our knowledge and reduce these resistance into 4. How we can reduce the 4 voltages into the level into 3? There are certain steps that we studied already, and now we are going to implement in this type of lectures. Let's start from very beginning. Before going to start, let us just recap the previous episodes what we discussed earlier. The first one is this is what we discussed already. If we have a voltage source and there are other branches connected to it, for example, this is our node 1, we can move this voltage source, what we call pushed through a node. So this is a scheme by which we can push this electrical voltage source through this node, either in this way or this way or this way. But there are some rules, there are some directions that need to be very carefully monitored. This is the previous episodes. In the next episode, we already discussed about how we can reduce the if we have a current source, for example, and in parallel with a passive element. This means it is in parallel, because here it is the rest of the network and we are not interested in rest of the network. So these are two parallel connected, the current source having a parallel passive element, not in series. Whenever we have a current source having a series element, then this is not the topic of our discussion. Okay, so this is beyond the study. Right now we understand, we learned the 3 basic steps. Number 1 is the push through a node. Second is if we have a current source having an element that is connected in parallel with the current source, can be converted into a voltage source having series passive element. So this is what we already learned. Okay, I mean, we can convert the current source into voltage source, but the restriction and first thing you have to be kept in mind, either there is a parallel or series. If this is parallel with current source, only this happens when this is in parallel with the current source, any passive element, and this is the vice versa process. We can also go back again. This is simple mathematics. Some steps are there. If you know the formula, you can easily apply these schemes, because resistance is very simple. So we started from the resistance. Resistance formula is very simple among the 3 basic passive elements that we earlier discussed in chapter number 1 of network analysis. Now we are studying the chapter number 3, and I wanted to tell you also one thing, that from the coming lectures we are moving towards simplification of the networks and understanding the basic anatomy of networks. That is started from in the form of examples. The main book that we are following is, again, I'm telling you, if some new students join us, is the network analysis, which I am using right now is the third edition by Van Valkenburg. Okay, you can download this book online or purchase or from the market. It is available very easily, or you can just follow the the main book has the coming up example session. I think 7 examples. One example will be discussed in the one episode, then the second example in the coming episode, and so on. But I am not sure that maybe my mind is changed in the coming lecture, so I will change my strategy, because I am not only following one book, there are maybe other books, so I can maybe skip and give you some task I provide you, and you have to perform by yourself. Okay, this is what 3 things we had discussed. Number 1 is a voltage source can be pushed through a node, and the second thing is if we can convert the voltage source into current source and current source into voltage source. Again, if we have a passive element with voltage source but in parallel with voltage source, this is beyond the study and not the matter of the discussion right now. This is not our topic because this has these discussions, these formulas are not applied to these type of terminologies. Okay, so today we are going to use these basically 3 steps and 3 terminologies, 3 type of understandings from last 3 episodes, and going to simplify a basic network. Let's suppose we are having a setup, a specific setup. We are going to apply the knowledge into this lecture. Okay, let's start. I'm first writing the basic electrical network. Let's suppose this is what I am having right now. Its value is 2 if I am not using the units, because I don't want to make sure that I have to make sure that my diagram is looking very simple. So sometimes I don't want to show the ohm unit here. It is understood that if 2 is written here, it means that 2 is its unit is understood ohm. So from here, this is our connection of the current source. Current source having 1, it means that 1 ampere. If nothing is shown here, it is understood 1 ampere. So we are if having let's suppose here we have an other resistance that is connected. This is our output. Output is taken from here, and this is our first terminal. Okay, this is another resistance and its value is 2, and another voltage source here. This is positive, negative. One thing you have to be very careful while drawing and choosing the networks, and that is the polarity of the current source, voltage source. This is very important, because again telling you that this type of terminology is mostly used. We already discussed in details about these things, because my task is to, I'm just repeating as a recap. It doesn't mean that we had not discussed. I know I discussed, and some students may be joined us right now in this lecture or previous lectures. So they might not seen the complete, they haven't time to watch all the session, all the episodes. So again repeating, this is a type of current source which having arrowhead, used arrowhead, which shows that the current, this is our positive and this is our negative in terms of voltage. I mean, if we wanted to show it in terms of voltage source, this should be the exact way. So that because it shows that the current direction is going in such a way that from left side towards right side, and this is also showing that the voltage is moving from left side towards right side. So this polarity should be kept in mind. Okay, so there are the 2 loops. You can see that this is the first loop, because it is a complete closed path. The current can be flowed from this point through this node and through this and back to the current source again. And another loop you can see that is from this point where my cursor right now to this point and then coming back, and this is a complete closed loop. But I'm not wanted to show you with the help of with the help of arrows, because it may complex our diagram right now. I wanted to show many other important things, so I'm just removing it right now. And our circuit is not completed here, and here we have an other resistance. Its potential is 3. So, and what we have other things, one second please. Yeah, we having a voltage source here, and that is the polarity of the voltage source. And this is the resistance, its value is 1, and we are having an other very important source, that is its value is 3. So, this is what we have, and this is the end of drawing the network. This is what all we have. So, from here you can see that this is the first terminal, this is the second terminal we are having. So, it means that we are, oh, one thing we forget is its potential. It is 6 volts. So, we have, our task is to reduce this network into a simple network. We can do this either, there are the two options. Our task is to make sure all the active elements are having the same category. Can be this is the best way to simplify this network. For example, you can see there are the 4 elements. If I wanted to count here, this is the first, this is second, this is third, and this is the fourth. So, the circle shows that this is just for the counting purpose, while the other 1, 4, 3 and 6 are the actually potential of these active sources. 1, 2 and 3, 4, total 4 sources are connected. First source, that is our current source, while second, third and fourth are our voltage sources. So, we cannot either, we can change the first current source into voltage source by what we already discussed here, that we can convert the voltage current source into voltage source, but we already discussed in the previous episode what is the best way, and we will try to discuss again in today's lecture, because this is our task. We either, this is the first option, by doing so current source can be converted into voltage source. By doing so, what we achieve, we actually achieved in having the same network of only voltage sources, exempt all the current sources are eliminated from the network. So, this is the first way. Second way is the convert the current voltage sources 2, 3 and 4 into current source, so that we are having all the current sources. I am choosing right now converting the voltage sources into current source, not the current into voltage, because this is a parallel network. You can see that this is the first loop and this is second loop, and 2 loops are connected with each other. So, this may create a little bit complicated networks. You can choose the voltage source as well. This is another practice, but I am choosing right now converting all the voltage sources into current sources. So, another important thing you have to keep in mind, that if we have the same type of elements, passive elements. Now, let us take a look at the passive elements. We are having 4 passive elements. All the passive elements are resistances, which means that they belongs to same category, and that is a very good thing, that we have all the passive element with the same category, that belong to the same category, which is a very good way, because we can reduce to 1. If we have having 100 passive element which belong to same category, we can reduce them to 1. But if there are 3 type of categories that we discussed, capacitor, inductor, resistor, are used in a network, which means that we can not reduce all the categories to 1. This may complicate the network. In the same way, if the 3 capacitors, we can reduce 3 capacitors to 1. But in today's lecture, we are using the resistor because it has most basic formula. Okay, I am using another color to make sure that this is the next step of discussion. This is again drawing. I am going to reduce this is to a current source that is connected here, having potential 1. I am not changing the current source, it is again here, but where is our voltage source? Here we have a voltage source, and I am going to replace this voltage source with a current source. How we can replace the voltage source with current source? I will also write the steps here, again recap, but before doing so I just wanted to tell you this is a voltage source in series. First of all, let's take a look. Before going to study any analysis, any discussion, any network, make sure that you having elements in parallel with voltage source or elements having series with the current source are only discussed. All other elements that are parallel with voltage sources, these are in series, that are in parallel with voltage source, as I discussed here, that are in parallel are beyond an exam. We are not going to discuss them. We are just, what we will do with them, there is a way. We will before going to analyze, the best way to do is actually short them, open them, because we are not interested in them. We will also discuss them, but later on. Okay, let's move back to it. One thing is understood. If this voltage source is removed and converted into current source, it is understood that it will come here in parallel with this resistance, because it is understood we are going to convert this voltage source into current source, then it will automatically change its series into parallel, because this is the requirement of the circuit. So the value of the resistance doesn't matter, changed. So because we cannot draw all the details here, just going to show you a basic understanding that we are in the previous lectures we used a very basic scheme and very basic understanding, where in the earlier episode you may have noticed that we, while converting the voltage source into current source, we used this type: V into T is equals to R1T plus V1T. This is just for the recap. And when we need a current source, I'm just writing the conclusion, the answer. I'm not writing all the details because we can't write here. For I is equals to V over R1. Sorry, one thing. This is not T. This is I. We need I from here. V over R, okay, R1, and this is what we discussed earlier. I am not going to show you about the proof, how it comes, why, from where it comes. Just go back and take a look at the previous episodes. This is the result, okay. What we achieved, I is equals to V over R1, V1 over R1. The V over R1 there is actually means that this is the voltage of, this is the current of the source. We are actually in that episode having a voltage source, and we converted this voltage source into current source, and when we convert this voltage source into current source, its polarity will be V over R. The simple way for this is to, this is the voltage through the resistor. We are not having considering the resistance, only this is required right now, because only the matter of the source is discussed right now, that is the having 4 actually polarity. First thing, always keep in mind that the polarity never changes. Actually, I mean that if we are having positive upper side, positive, then make sure that we again if we convert this into current source, its polarity like this one, because we are not going to change the current source in such a way that it disturbs whole network. If you choose the wrong side, then make sure you correct it, because the positive is upper side, so its arrow will be like this, okay. Now the main understanding is what is the value of this voltage source, what is the way. V is equals to IR. This is a very basic Ohm's law formula for any resistive network, okay. So if we are having we know the voltage, okay, we know the voltage, because the voltage is, the potential of the voltage is 4, it is understood. Now we want to derive the current formula. I is equals to V over R, and what is the value of the voltage? That is, I think 4 over what is the value of the resistance? This resistance, the resistance that was in series with the passive element, okay, not this resistance, not this resistance. Make sure that you choose the right resistance. 4 over 2, the answer will be 2. So this is a value if we converted the voltage source into current source. Earlier the voltage in case of the voltage source, it was having 4 value, which means 4 volts, but now when we convert it into current source, its value is changed and it will become the 2 ampere source. Now moving back and do the same thing with the other 2 sources that are connected in series with the passive elements. The best way to do is I am going to just connect them in a different fashion. This is our first resistance, this is our second resistance, and now it is understood that the 2 sources are going to be here and here because they are no longer connected in series. Okay. Now we have to also look at this value. Its value is 3 and the second resistance value is 1. It means that now important thing is to look at the arrow. Arrow is downside because positive is toward down, okay, and the positive is toward upside, so arrow head must be pointing upward towards up. What is the value? Value again with the V is equals to IR and apply the same formula. What is how we can apply? V is equals to IR and I is equals to V over R. I is equals to what is the voltage here? 6. Okay, 6 over what is the value of the resistance, that is 3. So which means that current is again 2. So what we will do here, actually just write 2 ampere. Again for this current I am again using I is equals to V over R. I is equals to what is the value of the V? V is 3. So 3 over what is the value of the R? R is 1. So 3 over 1, answer is 3. So 3 ampere is the answer, right answer. Now this is the simplified network. Going towards the next step, I am choosing another color to make sure that this is the next step towards simplification. Our task right now is to reduce these 2 resistance that are connected in parallel with each other into one resistance by step by step. Okay, as it is, and now 2 resistance are going to be replaced on the both loop, upper loop and the lower loop, by one resistance, and this is our output terminal. What I did is I connected the 2 loops with this wire. This is the best way to understand. Actually we will connect them again, but for avoiding the complexities, we connect these 2 loops and separated them and apply the same procedure to for the better understanding. So this doesn't mean that actually this means that these are connected with each other, but just because we are applying the separate separate operations to both loops, so for avoiding complexity and separating the both loops with each other, I just draw the simple one line, and it is understood that the both loops are connected and in series with each other. Okay, what we have to do right now, main task is what is the value. I know that 2 resistance, if they are either 100 resistance are there, because they belong to the same category, they can be replaced with one resistance, but task is what is the finally value there. So if there are different type of operations, if we have the 2 passive elements that are especially for example resistance, we wanted to reduce them to 1. First look at them, either these are in series or in parallel. There are different rule for series and different rule for parallel. The one resistance that we are going to replace, that is going to replace the two resistance, is called the equivalent resistance. I mean the new resistance that we are going to that is going to replace the earlier two resistance. The one resistance, this resistance, new resistance, is called equivalent resistance. Equivalent means the equivalent value of the previous, it is equal to the two resistance that we have in earlier in parallel. So in series we just add the value. For example, if there are the three resistance, we can add them. For example, let's suppose if we have the first resistance is 1 ohm and second resistance is 4 ohm, and if we have another resistance, let's suppose 5 ohm, then we can add in the similar fashion. Then overall equivalent resistance should be 5 ohm. So this is a series for series. And what if we have n parallel? Because our situation is two resistance in parallel, so we are going to choose this formula, that is 1 over R equivalent. That is, R is going to be in denominator and everything is in denominator, R1, R2, R3 and so on. Actually this formula is also in this can be written in this form, R3, R4 and Rn, but we are having actually two resistance and 1 over, what is the value of our R1? Go back and see, R1 is 2 and R2 is also 2. So as you can see, two resistors are connected in here parallel. Lower is also in lower loop, two resistors are again in parallel. So both will use the parallel connection formula. 1 over R1, what is the value of R1? 2. And what is the value of R2? 2. We need to go through using LCM, simple mathematics. 2 into 1, 2 and 2 plus 2, 4 over 2. Oh my god, I did actually mistake. Where is my mind right now? I'm out of my mind. Actually I was looking for the video length that is increasing, and I have to also understand this, that why my video length is going above 30 minutes, and this will definitely create a problem for me to upload and render it. Anyway, our 1 over R equivalent value is 1, which is 1 ohm, but it is understood 1 over 1 actually, and we need the value of R equivalent, not 1 over R equivalent. So what we need to do here is to divide by 1 over R, or go simple mathematics steps is invert 1 over R into R equivalent. R equivalent, if we are going to take this R into the numerator, definitely this one will go into the upper, and upper one numerator will go into denominator. Position is changed. So 1 over 1, because this is already 1, so 1. So upper value will be 1. So that what is the lower value? Again apply the same mathematics, because time is very short. I am going in very fast. 1 over what is the value of R1? I am going to see the value from my notes. You can look back 1 over 1 and apply the same 1 plus 3 and 4 over 3. Just look at this if I am wrong and correct me. 4 over 3 we cannot divide further. 1 over R equivalent, and we need R equivalent, okay, not 1 over R equivalent. So just change and replace the positions from 4 over 3 to R over 3. R equivalent would be 3 over 4. Replace the position, and this is the required R equivalent. So this is answer is, so the answer is 3 over 4. And what is the value of this first current source? It is 3, and it is, this is 1, this is 2, this is 2, and this is 3. So this is the third step. Before going to reduce, I am going to change the color for another step. Purple color will now indicate the fourth step. Again, as you can see that there are the two current sources, and we are now going to reduce the two current sources into one in the both loops. Same operation is going, and we are applying the same schemes in the both loops. As you can see that before going to proceed, you can see this current loop its polarity is going toward downside, and it also shows that after its current also going towards bottom towards down, and passing the same, I mean the current of the both sources follows the same direction when passing through the resistance. So this in the low, which means that we can simple add the current will be added. Okay, so we can replace the two current sources with one having the polarity like this, means its polarity is added. And here we go, we are having a resistance, and the value of this resistance is 1. Definitely there is no change in the resistance, but how we can add 2 plus 1 and it's 3. Simple. This is now done. And the second is again do the same thing in the second loop, but here you can see again the polarity is from bottom towards upside through the resistance, while this says that the polarity is towards downside. Now the contradiction can be seen in terms of the current flowing through the resistance. One source said the current must be from bottom side toward upside, while this other source said the current must be downside. So to solve this contradiction and the clash, we simple reduce. I mean that this current source is the larger 3 minus this current source 2. The answer would be 1. It is very simple. I mean the one current is flowing toward down, the second is going toward up. What will be there? There will be definitely the current will follow the majority direction. Direction will be definitely from 3 because its polarity is 3. If let's suppose this is current, 3 currents. 2 currents are going to clash with these 2 currents. It is cancelled. While the only one current, I mean one polarity, 1 ampere will be there, and it will flow easily from downside. So it means that the 2 ampere current from the both sources is going to be wasted in this war, while the 1 ampere current is there, and the polarity is definitely need to be considered. What is the polarity here? 3 over 4. 3 minus 1, 2, 1 ampere, okay, 1 ampere. But what is the direction? Direction is towards down. So towards down, okay, the direction must be from 3, which shows that towards down. Okay, you got this point. This is the 4th step. Now moving towards the 5th step. What is the 5th step? We can simple convert this voltage sources into current sources, because we wanted to connect them in terms of the voltage sources. Why we are going to convert these current sources into voltage sources, you can easily understand in the next step when I convert this. This is our resistance, and this is first voltage source, this is the connection, and this is the second resistance, and this is the second voltage source, and this is the output terminals, first terminal, second terminal. The first resistance value is 1, second resistance value is 3 over 4, and how we can convert and what is the direction actually need to be definitely considered. Direction will be positive, negative, because you can see it is upward, so it is upward. So what is the direction of the downward? Its direction is again the same. You can see upper side, so which means that positive, negative. And what is the value? Their value is the main task, because their value needs to use again Ohm law. We are now going to apply I is equals to V over R. This is the formula we earlier used. Now V is equals to I R. What is the value of the V? First choose the value of the current and then resistance. What is the value of the V? I is here 3. We are having the 3 ampere current source. So just apply 3. What is the value of the resistance? The resistance must be that one that is connected in parallel with the current source. So 1. So 1 is the right value. Just add here 1. V is equals to 3 volts. So the first voltage source must be 3 volts. What is the second voltage source? again apply the same knowledge. Because I am short of the time, I am just writing here, it would be 15 by 4. You can choose and try by yourself. So this is the fifth step, I think, and the last and the final step. This is the this can be further simplified. How we can further simplify this? You can see there are the two current sources and two resistance. Two current voltage sources that are connected in the same pattern in a series. Where in series, if the two voltages are connected, their voltages are always summed. I mean, this resistance, there is only one resistance. Two resistors are connected in series and two voltage sources. There was only one voltage source is needed. This can be replaced easily. And what is the way? 3 plus 15 over 4. Just add them. And if the current, because both are currents, both voltage sources are going from bottom side towards upper side. So the polarity is same. That's why I am adding them. So the best way to add them is to show in this way. So sorry, I did actually a mistake there. This is not the value of the voltage source. It is 3 over 4, and here it is 15 over 4. I saw from my notes 3 over 4, and after it is 3 plus 3 over 4, and the answer is 15 over 4. So it is actually 15 over 4, because I I saw from my notes, mistakenly I saw the next picture and I write it here. It is actually 3 over 4. Okay. So what is the value of the resistance? Again, because it is connected in series, use the series formula. What is the formula for the series? 1 plus 3 over 4. Because time is very short, I am not going to going in details. This is 4 and 4 plus 3, and you can choose by yourself, and it is 7 over 4. So this is the simplified form for the resistance. What if we need in the terms of the current? Again, you can go in the next step. And what is the next step? You can this is your homework, because time is short, and that's very good for also us. You have to convert this voltage into current, and what is its polarity, either upward, either downward. This is your task, that what is the value and what is inside value. So next time, inshallah ta'ala, take care. Allah Hafiz.